Hey there, algebra students. Just creating a video to help you with your Friday lesson this week on lesson 13. Just a forewarning, this lesson does get a little bit hairy, a little bit difficult, but just do your best this Friday and be prepared to dive into conversation on Monday. So here we go. We are in lesson 13, page 105. If you do not have your book, please pause it now, the video now, and go get it. All right, so the first thing I'd like you to do is jump into this warm-up where you need to take an expression that's either in standard form, make it factored form, or put it from factored form over into standard form. So please pause your video now and work through these to the best of your ability, and then come back. All right, algebra. So here we go. Let's go over these. So hopefully that one's pretty straightforward. X squared being x times x. Okay, let's go down. Still pretty straightforward. You're just distributing the x. Make sure that you make that 9x as well. Now some of you, this is called factoring, to put it in factored form. And if you're struggling with this step, I wouldn't be surprised since we haven't done a lot of it. So just what you have to do is you have to notice, is there a common factor with both of these terms? And notice how there's at least one x in both of them. There's not a coefficient up here, so there's not a shared number or a shared numeric factor, but they both have an x, so we can pull out that x and makes it x, parentheses, x minus 18. Please note that this skill right here of factoring is very important moving forward with algebra. And so please take every moment to think about this and to get the idea down to heart. This is not an idea that we're going to deal with briefly and then move on from. Okay, moving forward, we see here that we are distributing this, but I want to point out something that I did. Notice how this in parentheses has 6 minus x, and then I rearranged the terms after I distributed, keeping the negative sign with the x squared. That way it could be in that standard format that I've spoken about, in which we start with the x squared term, and then we address the linear term, and then if there was a constant, that would be at the end. Okay, here we have one more time we factored out. Notice I factored out the negative with the x. I wouldn't be surprised if many or all of you did not do that, but make sure you factor the negative out so that you're left with just x minus 10. Why minus 10? Because negative x times negative 10 is positive 10x. And then here we have a case where we just distribute the negative, and this should not have said plus 2.75, but rather minus. Okay, so students, moving down to the next section, we have more experimenting with Desmos. And I would say that please just jump on Desmos. If for some reason you are not allowed to or able to get online and to use Desmos, maybe your parents have said no computer access today, or maybe you just have only one computer and it's being used by someone else and you weren't able to do it. Please make sure you have a little note for me letting me know. But just like the other day, just plug these equations into Desmos and experiment, and then just record some observations. Okay, and that's it. Try to see if you notice what happens when you do certain things. Then moving to the next page, this should be familiar to you, except for one thing. When we did a table like this before, it was in factored form, not in standard form. So you are going to have to factor these. You're going to have to factor those. And let me just do one that's maybe more tricky for you. So I'm looking at this and I need to see, what does this term and that term have in common? Well, there's no numeric coefficient, so they don't have any common numeric terms, but they do both have a negative and they do both have an x. So I will just make this negative x times the quantity of positive x plus 36. And then hopefully that makes it a little bit easier to spot your x-intercepts and then the x-coordinate of the vertex. Just a reminder, you find that x-coordinate of the vertex by looking at the number that's between your two x-intercepts. Okay, students, go ahead. Oh, I forgot to cover that up. So go ahead and try to factor that. And if you struggle, that's fine. And I do not spend like more than a minute and a half on these two questions. We will go over those on Monday. All right, so then here we get to the trickier part of this lesson, which is they want you to come up with the equations for these. Some of them are going to be fairly easy. Some of them are ones like we've done before. I will just tell you right here, right off the bat, this one, notice how it only has a singular x-intercept, and it's a fairly standard looking parabola. So just think, what is the most basic quadratic equation you could come up with? Now, here's the deal. In the directions, they say use your graphing technology. Okay, so have Desmos open. Try your equation. See if it looks like the picture. And if it doesn't, see what you may need to modify in order to make your equation match the picture. Okay, so on a lot of these, it's really going to be about identifying your x-intercepts and writing your equation in factored form. Okay. And I would say for most of these, that's the case. But then you do get to some that are more tricky and tie into those observations that we briefly talked about on Thursday in class, and which you may have observed through your Desmos explorations. So for example, this one, it's still mainly about your x-intercepts, but notice it's upside down. What do you do to make it upside down? Notice over here, your vertex, you only have one x-intercept, and it has shifted over to the right. How do you do that? Okay, notice, let me see what some of the more tricky ones are. I think actually the most tricky ones are going to be these last ones. So students, the last thing for you is that I am including an answer key for these questions in your Plus One Friday folder. Please keep that sheet folded, unless, and you don't even have to use it unless you have finished this or you get really, really stuck, okay? So then, besides that, I'd like you to do practice problems, question 1. Move on to the practice problem. Please also do question 2. Question 3. Question 4. And question 5 is optional. You do have to use Desmos for that one. And go ahead, a 6 is a good review. Work on those practice problems. Hopefully this lesson is less than 40 minutes. If you spend less than 40 minutes, make sure to let me know on Monday. Students, I hope you have a great weekend. Enjoy some time outside and quality time with your family. We'll see you later, guys.